Okay, good afternoon, everyone. So our topic for today will be about amplitude modulation. So our AM. So fundamentals muna tayo. So what are the objectives? Ano yung after this discussion or maybe after this topic, ano yung dapat ninyo na um, kayang gawin? Okay, ano yung dapat yung matutunan? So you should be able to calculate the modulation index and the percentage of modulation. Of course, given ng amplitudes of the carrier and the modulating signal. So ano tong mga carrier, ano tong modulating signal? And define overmodulation and explain how to alleviate its effects. Explain how the power in AM signal. So maybe in continuation, we can discuss more about power in the AM signal. Compute sideband frequencies and time domain, frequency domain, and phasor representations of an AM signal. Okay, so as you know, in the modulation process, the the baseband, yeah, the baseband voice, video, yan, or digital signal, uh, yan, modifies another yan, high frequency signal. We call it a carrier, okay, which is usually a sine wave. Tandaan na, the carrier is the baseband voice, okay, or video, digital signal. So a sine wave carrier can be modified by the intelligence signal through the amplitude modulation. So isa lang yan, AM na modulation. Meron din tayong frequency modulation or phase modulation. Okay, pero for now, we'll be focusing on amplitude modulation. Okay, so meron akong term dito, envelope. Ano tong envelope na to? So let's start with this illustration here. Okay. This shows or this graph shows the modulating or information signal. Okay, sinusoidal modulating wave. Okay, yung V sub M here is the peak, the positive peak value of the modulating signal. Now, so yung sa previous slide natin nabanggit ko kanina, 'di ba, yung envelope. So an envelope is an imaginary line connecting the positive peaks and negative peaks of the carrier waveform. So sa next na illustration natin, ito yung modulated carrier. So you can see here the envelope. Ito yun, imaginary line na to of the, it's an imaginary line connecting the positive peaks and negative peaks of the carrier waveform. Okay? So it actually gives the exact shape of the modulating information signal. Okay, yun yung envelope. Now, so in this figure, okay, as you can see, okay, yung unang, ito kanina, this shows a single frequency sine wave intelligence signal, yun yung tawag natin, other term natin, modulating a high frequency carrier. Tandaan na yung carrier mo is a high frequency. The carrier frequency remains constant during the modulation process. Pero yung amplitude niya, yun yung nagva-vary in accordance dun sa modulating signal natin. Okay? Kaya ito yung lalabas, 'di ba? Constant yung ating carrier but because nagva-vary lang siya yung amplitude niyan pag nag-undergo na siya ng modulation na process. Okay? And yeah, this shows the simplified method of representing an AM or amplitude modulated, yeah, high frequency sine wave. So this is the modulating signal envelope. Ayan. In this one, equally spaced vertical lines represented constant frequency carrier sine wave. So ito yung carrier signal mo. Usually, di ba, mataas yung value niyan. Okay, so yung signal na to or shows the variation of the carrier amplitude with respect to time. Okay, with respect to time. And are said to be in the time domain. Now, time domain signals like voltage, current, and um, are displayed on the screen of the oscilloscope, di ba? Nakita niyo yung oscilloscope na nakagamit na kayo nun? Okay, now let's focus on some of the calculations dito, yung mga terms. Okay, so you know that kanina sa figure natin, you have the modulating signal or information signal, you have the carrier signal. So using trigonometric functions, we can express the sine wave carrier with a simple expression. Tandaan na, sine wave carrier signal. V, C, sine 2 pi Fc, ang carrier frequency po yan. Tandaan na. So yung VC, ito, this represents the instantaneous value of the carrier sine wave. Ito naman yung V sub C natin. Ito yung peak value of the constant, tandaan, unmodulated carrier sine wave. Okay. Tapos, naka-region measure tayo ha kapag sa ganitong calculation, di ba? Sine 2 pi, ayan, times the carrier frequency. Ang carrier frequency is yung mismong carrier sine wave natin. Okay, tapos yan, time. T is a particular point in the point in time during the carrier cycle. Now, we have a sine wave modulating signal. Ito yung formula natin. So, V sub m equals, yan, V sub m sine 2 pi f. Tandaan yung pinagkaiba nila ha. So, peak value, yung itong big letter or capital letter na to. So, yung small letter naman is for instantaneous, okay, value ng information signal natin. Tapos yung F sub m natin, this is the frequency of the modulating signal. Okay, tandaan ha, this is the formula for a sine wave modulating signal. Okay, modulating signal. Ito naman, again, this is the sine wave carrier signal natin, unmodulated. Okay, so in amplitude modulation, and to give you a background, it is important that the peak value of the modulating signal should be less than the peak value of the carrier. So, mas mataas yung carrier mo, peak value ng carrier mo, compared dun sa modulating signal, sa peak value ng modulating signal. So, ano bang mangyayari kapag mas mataas yung modulating signal mo compared dun sa carrier signal? So, ang mangyayari lang, mga kapatid, magkakaroon tayo ng distortion. Okay? So, you should remember that the modulating signal, okay, should always be, less than the peak value of the carrier. Okay? So, values for the carrier signal and the modulating signal, we can use this sa formula na to sa next page natin. Ayan. V sub 1. Yung V sub 1 natin, this is the instantaneous value dun sa taas at baba ng voltage envelope natin. Kanina sa figure. Balikan natin yung figure. Ayan. Taas, baba. So ito yung envelope natin. V sub 1. Okay, yung V sub 1 is equal to the sum, okay, carrier tapos instantaneous na value ng modulating signal natin. Or this V sub m, based on sa formula natin kanina, is equal to the peak value of the modulating signal times sine 2 pi frequency ng modulating signal times time. Or, yan. And then yung V sub 2 naman natin, yung V sub 2 is the instantaneous value of the AM. AM naman na wave, which is equal to V sub 1 sine 2 pi f sub c t. Okay? Itong V sub c sine 2 pi, diba, if you remember, it's a carrier waveform. Okay? And yung V sub m naman natin, sine 2 pi ft multiplied to sine 2 pi ft is the carrier waveform. Ayan. Multiplied by the modulating signal. So this is now the result of yung V sub 2, instantaneous value of the AM. Ito na yung AM natin actually na equation. Okay, so you have, plug in lang natin dito. Di ba ito yung ating V sub 1, right? So this is equal to V sub C plus V sub M sine 2 pi F sub MT. Plug in natin dito. So simplify lang natin. So we have this equation now of the AM instantaneous value. Okay. And ano pa yung kailangang malaman natin? Carrier waveform, modulating signal. Okay. Now we have what we call the modulator. Ano yung modulator pala? The circuit used for producing AM is called modulator. Okay? So it's two inputs. Yan. The carrier and the modulating signal. Yan. Modulating signal, V sub M, or information signal, intelligence signal, yun yung other terms. And carrier signal, ito yung two inputs. Yan. And the resulting outputs, as you can see here, yung V sub 2 natin, ito yung AM natin, or amplitude modulated wave, right? Okay, so amplitude modulators compute the product of the carrier, okay, the carrier and modulating signals. Okay. Circuits that compute the product of two analog signals are also known as, anong tawag doon? Analog multipliers. Pwede rin sabihin na mixers, converters, product detectors, and phase detectors. Okay, tandaan na yun yung term na ginagamit pagka i-compute natin yung product ng carrier and para malaman natin, ano yung gagamitin natin na circuit, okay, to compute the product of the two analog signals. So mixers or multipliers or detectors. Okay, so again, a modulator is a circuit that changes a lower frequency baseband, or we call it the intelligence signal, to a higher frequency signal. Okay, so we call it modulator. Now, ano naman yung kabaliktaran nun, di ba? Ano yung circuit na ginagamit para ma-recover natin yung original na intelligence signal? We call it detector or demodulator. Okay, this is a circuit used to recover original intelligence signal from an AM wave. Yung mixers, may separate discussion tayo with the mixers and detection na application. Okay, so firstly, yung unang parameter natin for computation is we need to know yung modulation index. Okay, so for undistorted na AM to occur, the modulating signal or yung V sub M natin must be less than the carrier voltage signal. Di ba? Nabanggit ko kanina, kasi kung mas mataas yung modulating signal mo, may distortion na mangyayari. Okay, so therefore, the relationship between the amplitude of the modulating signal, yan, and the amplitude of the carrier signal is very important. Okay, so yung ratio na to, we call it, tawag natin is the modulation index. Okay, tandaan na, modulation index, or we have another term for this, modulating factor or modulating coefficient. So maaring ganun yung ibibigay ko sa quiz, di ba? May other term na gagamitin. So tandaan na, same lang yan sila. Modulation index, modulating factor, or modulating coefficient. Or pwede rin degree of modulation. Kapag ganun yung term na nakita nyo, it's actually the ratio of the amplitude of the carrier signal, the modulating signal over the carrier signal. Okay? The carrier voltage is, tandaan na, this is the unmodulated. Pag sinabing unmodulated, di ba? Yun yung high frequency signal natin. Okay? This is the modulated. Okay, the amplitude of the modulated signal. Now, how to determine the percent of modulation? So, yung sagot natin dito sa ratio na to, multiply lang natin by 100 and we can actually determine the percent modulation or percentage of modulation. For example, if the carrier voltage is 9 volts, okay, tandaan na, the carrier voltage or unmodulated signal is greater than the modulating signal. Okay, so basically, yung modulation index natin for an AM should be, for a good AM, dapat hindi siya lalagpas ng 1, di ba? Or less than 1 siya. Yeah. So 7.5. 7.5 divided by 9 is equal to what? Kung tama yung pagkalculate, 0.8333. So if you want to determine the percentage of modulation, so you just multiply that by 100 and you get 83.33% or percentage of modulation. Okay? Tandaan ha, kasi pagka sumobra sa 1 yan, yan, overmodulation, di ba? Or distortion. Clear tayo? So paki-note na lang, the modulation index should be a number between 0 and 1. Okay? Kapag if the amplitude of the modulating voltage is higher than the carrier voltage, the modulation index will be greater than 1, which will cause what? Distortion of the modulated. May picture ba ako ng andito? Distorted na. Wait, ay wala. Okay. May distortion do sa modulated waveform. So kapag mataas yung distortion, anong mangyayari? Yung ating information signal or intelligence signal, hindi na siya mababasa, di ba? Or unintelligible na siya. So, hindi mo siya matatransmit yung information signal. Distortion of voice transmission produces harsh, garbled, and unnatural sounds in the speaker. Ganun. Pag sa video naman, yung distortion, nagpo-produce siya ng scrambled and inaccurate picture on TV screen. So kapag nakita mo na, okay, scrambled yung mga pictures doon or inaccurate, distortion yun. Okay? So hindi natin gusto yung ganun na reception na may mga distorted images or yung voice na hindi masyadong clear. Okay? Now, our next okay, ano pala yung term na overmodulation? Hindi ko nabanggit sa inyo. Pag sinabing overmodulation, it is the condition where the modulating voltage is greater than the carrier voltage. Nakuha? So, madaling intindihin naman, di ba? Overmodulation. Gets? Okay. Now, let's go to this figure here. So I'm showing you an AM wave, yung peaks niya, yung Vmax, and yung troughs naman is Vmin. Okay, nakita niyo sa figure na to. Ito naman, ito yung Vmax. Tandaan, ito yung modulated natin, amplitude modulation na waveform. Yung Vmin, ito yon, minimum voltage na peak. Ito, or actually trough. Trough siya. Yung peak natin is Vmax. Okay. Vmin peak to peak, takas Vmax peak to peak. Okay, so ano yung gusto kong iparating dito? So when the AM signal is displayed in oscilloscope, actually, the modulation index can be computed from Vmax and Vmin. Okay? Ano yung peak value? The peak value here, the peak value of modulating signal na V sub M is what? 1/2 ng difference nila ng peak and trough values. Tandaan na, Vmax minus Vmin over 2 or 1/2 ng difference nila is equal to the modulating signal. Dapat yun ang lalabasan. Clear? Now, the peak value, the peak value of the carrier signal or V sub C is the average of the Vmax and Vmin values. So V sub C, actually na-produce ito by, utilizing din yung idea dun sa unang, ito sa modulating signal natin. Okay, so as you can see here, balikan natin yung figure dito. Okay. Nakita nyo, di ba, yung Vmax? Di ba, yun yung peak value ng ating signal. Ito ay peak value during the modulation. Tapos yung Vmin naman is the lowest okay, value or the trough of the modulated wave. So yung Vmax is actually one half the peak to peak. Tama? Peak to peak value mo, one half of the peak to peak value of the AM signal. So, ayan, kapag sinubtract natin yung Vmin from Vmax, it produces the peak to peak value of the modulating signal. Okay, so one half of that peak value na yon. Okay, so again, this is the carrier signal V sub C, the peak value of the carrier signal, which is equal to Vmax plus Vmin over 2. Now, pwede natin ma-derive, di ba? If you remember, yung ating modulation index is the ratio of V, the peak value of the modulating signal natin over the peak value of the carrier signal. So, ayan, makancel lang natin yung one half dyan. So, pwede natin ma-determine yung modulation index utilizing Vmax, yung peak value, okay, yung peak and trough. Nakuha the lowest value of, dun sa ating modulating, sa AM natin na modulated AM wave. Okay, so example number 1, suppose that on an AM signal, the Vmax, yan, naka-indicate naman na peak to peak siya. So kalahati nun yung kanina is pwedeng gamitin sa formula. Yan. From the graticule of the oscilloscope screen is 5.9 divisions and V min natin, peak to peak is 1.2 divisions. Now, what is the modulation index? So the modulation index is equal to Vmax minus Vmin, okay, over Vmax plus Vmin. So to determine the Vmax, yan, so we are given, di ba, 5.9 division. So 5.9 minus 1.2 over 5.9 plus 1.2 is equal to 4.7 over 7.1, or the modulation index natin is 0.662. Okay? Ano pa? Calculate the carrier, the peak value of the carrier, the peak value of the modulating signal, and the modulating index if the vertical scale is 2 volts per division. Okay, so meron tayong naka-indicate na 2 volts per division. So multiply lang natin dito mamaya sa 2 volts per division. Kasi ang unit natin dito will become number of divisions, di ba? So Vmax plus Vmin is over 2. So we have 5.9 plus 1.2 divided by 2 equals 7.1 over 2, which is 3.55 divisions. We need to know the voltage value, so times 2 volts per division. So the answer to this is 7.1 volts. For the peak value of the modulating signal, we have Vmax minus Vmin, and then multiply to 2 volts per division to determine the peak value of the modulating signal, which is 4.7 volts. Okay? So the same pa din naman yung makukuha natin. Okay, na value for the modulation index. Okay, so we now have another parameter na isa sa mga ating ko consider, guys. So whenever a carrier is modulated by an information signal, new signals at different frequencies are generated as part of the process. Okay, so these new frequencies, we call it what? Side frequencies, okay, or sidebands. So this occur in the frequency spectrum directly above and directly below the carrier frequency. So more specifically, the sidebands occur at frequencies that are the sum and difference of the carrier and modulating frequencies. Okay, so when signals of more than one frequency make up a waveform, it is often better to show yung AM na signal natin in the frequency domain rather in the time domain. Okay, so take a look at this illustration here. So I have the AM wave. Okay, the AM wave is the algebraic sum of the carrier, di ba? Ito yung AM wave natin. Of the carrier and the upper and lower sideband sine waves. So yung itong nasa A natin, ito, we call it the intelligence, di ba? Or information or the modulating signal. Yung B naman natin, this is the lower sideband. And then yung letter C, we call it the carrier. Yan. Carrier signal natin. And then letter D, we call it the upper sideband. And for letter E, this is now the composite, di ba? AM wave. Yan, algebraic sum of the carrier and upper and lower sideband sine waves. Okay. So yan yung makikita nyo sa oscilloscope kapag meron kayong AM circuit. Ha? Yung variations dun sa amplitude ng carrier with respect to time. Now, so how do we calculate the sidebands? So here, yan. Nabanggit ko kanina, di ba? When only a single frequency sine wave modulating signal is used, the modulation process generates two sidebands. Okay, pakitandaan ha, when only one or single frequency sine wave modulating signal yung ginamit natin, there are two sidebands na mag-generate. And if the modulating signal is a complex wave, like yung voice, video, yan, a whole range of frequencies modulate the carrier. Okay? So madaming range ng sidebands yan. So here we have the upper sideband F sub US, FUSB, upper sideband. Lower sideband LSB, ito yung frequency. This is how you determine where F sub C is the carrier frequency and F sub M is the modulating frequency. Now, the existence of sidebands can be demonstrated mathematically using the equation or starting the equation for an AM signal na ating na-derive previously, or pinakita ko sa inyo yung derivation, which is equal to V sub C sine 2 pi, this is in radian measure, okay? The carrier frequency times the time. And then, yeah, V sub plus V sub M. This is actually multiplied the entire equation by sine 2 pi F sub T. Okay, so next slide. Ayan. So gamit yung AM natin na equation. So by using trigonometric identity, ayan, that says that the product of two sine waves is, ayan, sine A times sine B is equal to this one half ng cosine A minus B. Ayan. Minus cosine, okay, wait. Cosine A plus B. And substituting the identity into the expression ng modulated wave natin, which is ito, we just substitute in here. This will result, ito na yung ating, yung first term natin dito is the carrier. Ayan, the second term natin, pag na-simplify na guys, the second term is, it contains your carrier frequency and the difference actually, which is the lower sideband, no? And then the third term, it contains yung formula kanina, ayan, for upper sideband, yung sum lang ng carrier and modulating frequencies. Okay. So, ano pa? So, assume that 400 Hertz tone modulates a 300 kilohertz carrier. Okay. Tandaan na yung carrier signal natin, mataas yung frequency niya. Okay. So, the upper and lower sidebands are, so this is how you determine. So, 300 plus 400, yun yung upper sideband frequency natin. Pag minus naman, you will get the lower sideband frequency, which is equivalent to this. So apply mo na sa ating AM wave. So yan yung equivalent natin na instantaneous amplitude ng ating AM wave. Okay, so I think we'll continue with determining the power. Yan. In AM, next meeting na lang siguro. Okay, any questions so far, guys? Sa AM, amplitude modulation, the modulation technique, fundamentals, ano yung carrier. Yan. Let's have an assessment later siguro para yan, to be to make sure that you are familiar with these concepts or fundamentals in amplitude modulation. So, binavary natin, di ba, yung amplitude ng signal. Okay, since wala naman kayong tanong, let's watch this video. So this video is about radiation. Ayan, sabi ko kanina, so we'll have, every time na may lecture tayo, we'll have a video of the day. Ayan. So let's watch this. This video is actually from TED Ed. If you're familiar, very educational, informative na video. So, is radiation dangerous? So, depende kung anong klaseng radiation. So, let's watch this. Okay, ready? Let me play this video.
When we hear the word radiation, it's tempting to picture huge explosions and frightening mutations. But that's not the full story. Radiation also applies to rainbows and a doctor examining an X-ray. So what is radiation really, and how much should we worry about its effects? The answer begins with understanding that the word radiation describes two very different scientific phenomena: electromagnetic radiation and nuclear radiation. Electromagnetic radiation is pure energy consisting of interacting electrical and magnetic waves oscillating through space. As these waves oscillate faster, they scale up in energy. At the lower end of the spectrum, there's radio, infrared, and visible light. At the higher end are ultraviolet, X-ray, and gamma rays. Modern society is shaped by sending and detecting electromagnetic radiation. We might download an email to our phone via radio waves to open an image of an X-ray print, which we can see because our screen emits visible light. Nuclear radiation, on the other hand, originates in the atomic nucleus, where protons repel each other due to their mutually positive charges. A phenomenon known as the strong nuclear force struggles to overcome this repulsion and keep the nucleus intact. However, some combinations of protons and neutrons, known as isotopes, remain unstable or radioactive. They will randomly eject matter and/or energy known as nuclear radiation to achieve greater stability. Nuclear radiation comes from natural sources like radon, a gas which seeps up from the ground. We also refine naturally occurring radioactive ores to fuel nuclear power plants. Even bananas contain trace amounts of a radioactive potassium isotope. So if we live in a world of radiation, how can we escape its dangerous effects? To start, not all radiation is hazardous. Radiation becomes risky when it rips atoms' electrons away upon impact, a process that can damage DNA. This is known as ionizing radiation, because an atom that has lost or gained electrons is called an ion. All nuclear radiation is ionizing, while only the highest energy electromagnetic radiation is. That includes gamma rays, X-rays, and the high energy end of ultraviolet. That's why, as an extra precaution during X-rays, doctors shield body parts they don't need to examine, and why beachgoers use sunscreen. In comparison, cell phones and microwaves operate at the lower end of the spectrum, so there is no risk of ionizing radiation from their use. The biggest health risk occurs when lots of ionizing radiation hits us in a short time period, also known as an acute exposure. Acute exposures overwhelm the body's natural ability to repair the damage. This can trigger cancers, cellular dysfunction, and potentially even death. Fortunately, acute exposures are rare, but we are exposed daily to lower levels of ionizing radiation from both natural and man-made sources. Scientists have a harder time quantifying these risks. Your body often repairs damage from small amounts of ionizing radiation, and if it can't, the results of damage may not manifest for a decade or more. One way scientists compare ionizing radiation exposure is a unit called the sievert. An acute exposure to 1 sievert will probably cause nausea within hours, and 4 sieverts could be fatal. However, Our normal daily exposures are far lower. The average person receives 6.2 millisieverts of radiation from all sources annually, around a third due to radon. At only 5 microsieverts each, you'd need to get more than 1,200 dental x rays to rack up your annual dosage. And remember that banana? If you could absorb all the banana's radiation, you'd need around 170 a day to hit your annual dosage. We live in a world of radiation. However, much of that radiation is non ionizing. For the remainder that is ionizing, our exposures are usually low, and choices like getting your home tested for radon and wearing sunscreen can help reduce the associated health risks. Marie Curie, one of the early radiation pioneers, summed up the challenge as follows: "Nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less."
Okay, so thank you very much dun sa video na to from TED Ed. Okay. So, kamusta naman kayo dyan? I hope you learned something today aside
Thank you,
from,
sir.
the video that I have just shown you. Yeah. Anyway, sige. So if you want to know your grades, you can stay put. And ma-share ko lang din regarding sa radiation kasi nung nag-work ako dati sa isa sa mga companies dyan sa EPSA ba yun? Tama, sa EPSA. Yun, meron kasi kaming equipment doon na X-ray, nag-X-ray ng mismong mga device namin. So meron kaming sinusuot na talagang special suit for anti-radiation, or parang meron kaming, nakalimutan ko na yung term na yun na ginamit. Yun nga, tatama nga yung sievert na for measuring, 'di ba, yung exposure sa radiation. So yung too much exposure, syempre harmful siya. Yeah, ganong radiation. Anyway, so that's all. May mga tanong ba kayo? None? So we can
Wala
proceed
pa
na.
naman po.
Okay. So next week ulit, next week ulit, we'll have another, featured video. Yan, for you guys. Syempre related sa electronics and communications. Okay?
Thank you, sir.
Okay. Welcome.